Yo, what's up, Sci Fam? It's your boy Nickel. I'm here with the introduction to one of the science experiments that you're going to use to collect some data. So we're going to create a greenhouse effect in a Erlenmeyer flask or in a beaker here. And we're going to set this up in a way that we have one that's a greenish blue. This one will be our control beaker. We'll also have a beaker that's got some red writing on it, and this one will be our test beaker. So as everyone says, as we add more carbon dioxide to our atmosphere, the temperature of our Earth is going to increase. Well, if that's true, then if we add more carbon dioxide to one beaker, then the temperature of the air in the beaker should also increase. Okay, well, let's set this up. So I've got two stoppers here which fit on the top of these beakers, so the air cannot really get out. If we put CO2 in, we don't want it to escape. In order to insert the carbon dioxide, I've got some effervescent anti-acid pain relief tablets. Now, if I look at the actual ingredients of these tablets, well, what does it say? Oh, here it is. It includes sodium bicarbonate. Now that sodium bicarbonate, when it's put into water, it dissolves and it releases the carbonate, or the carbon dioxide, when it dissolves in the water. So it's a way that we can basically add some fizziness to our water that then releases from the water and enters the air in the beaker. It's the same thing if I were to get some seltzer water and pour it in here. That seltzer that's in the water is basically an Alka-Seltzer tablet, so that's why we call it seltzer water, and it has CO2, it's carbonated. So I've got a container of water here, so we want both of these beakers to be as similar as possible. We want all the variables to be the same between them, except the one thing that we're going to add to this one beaker is an effervescent Alka-Seltzer tablet that will then provide the CO2. So both of them need to have equal parts water. All right, water is in both of my beakers. I'm now going to open up one of my tablets here, and I'm going to break it into two pieces just so that I can definitely fit it in my beaker. Look at that. You can see the carbon dioxide forming in the water as those tablets start to dissolve. So I want to make sure I trap it in the beaker, so let's get it back over here and let's attach a stopper onto the beaker top. So remember, this one, the only difference is that one of them gets carbon dioxide, the other one doesn't. I'm going to place a piece of masking tape here on the top of the stopper of both of them so that air cannot escape or enter. Now, this one just has the air of the classroom inside of it, so this is going to be our control. This is what it normally is like. Now, I could do a new experiment and add one that just has oxygen in it, but for the ease of the experiment, I'm just going to leave this with our normal air, and this one has the tablet in it, which you can see those bubbles really clearly now. It almost looks like Sprite is in this beaker, and that's just the CO2 that is coming from our tablet. Okay, so the next thing that I'll do is I will place both beakers in front of the heat lamp, which will be set up in class. Now the heat lamp will be much closer to the beakers so that it will help heat up the air that's in there. But again, if one of them has carbon dioxide and one of them doesn't, you should have some initial hypotheses about what you should observe if you take the temperature of both of them. So when it comes time to take the temperature, you're going to use these handy dandy thermometers, and you're going to poke it through the hole that's here on the top of our stopper. You're going to place it into the beaker so that it enters the air, not the water. You're going to turn it on, and you're going to take your reading. You should do this probably every about 2 minutes to see how the temperature changes over the class period time that you're in science class. So you can use the same thermometer if you would like. If you do, though, make sure that it stabilizes in temperature before you add it to the next beaker, or you could use two separate thermometers to get the temperature of the air that's in the beakers. All right, collect your data, and let's see what we find.